Solve the system. All right, so the first equation here is not linear. The second equation is linear, but that makes the system overall nonlinear because the first equation is not linear. In order to solve a system of nonlinear equations, the two main techniques would be substitution and elimination. You could also solve the system using a graphical approach, which is actually quite useful, but in this particular case, I'm going to demonstrate how to solve the system using substitution. So what I'm going to do is I'm going to solve one of the equations for a variable and then use that as a substitution for the equation that I didn't use. So let me demonstrate what I mean. We're going to take the second equation here and we're going to solve it for x, let's say. So x plus 2y is equal to 4. If we subtract 2y from both sides, that'll end up giving you that x is equal to 4 minus 2y. All right, so our new system of equations is going to become x squared plus 4y squared is equal to 16, and then x is equal to 4 minus 2y. Okay, from there, what we're going to do is we're going to take the second equation and we're going to substitute it in for x in the first equation. So we're going to have space squared, in other words, x squared, we'll leave a space for that, and then we're going to have 4y squared is equal to 16. And in the space, we're going to plug this in because that's what x is equal to, 4 minus 2y. All right, so if you're squaring that, you're basically just multiplying it by itself, so 4 minus 2y times 4 minus 2y plus 4y squared is equal to 16. So 4 times 4 is 16, 4 times negative 2y is negative 8y, negative 2y times 4 is negative 8y, and negative 2y times negative 2y is positive 4y squared. Then we have plus 4y squared equals to 16. Let's combine like terms then. So we'll have 16, here we'll have minus 16y, and then here we'll have plus 8y squared is equal to 16. If I subtract 16 from both sides, I lose those 16s there. So I have minus 16y plus 8y squared is equal to 0. All right, from here I can certainly factor out the common term, which is 8y from both pieces. So it'll leave me with negative 2 here in the back plus y. And that's equal to 0, right? Of course, you can confirm that if you distribute this back in, you will certainly get what we started with, right? Negative 16y and positive 8y squared. Okay, but we now have a product that's equal to 0, so we can separate these pieces and set them equal to 0 separately. So we should be able to say that either 8y is 0 or negative 2 plus y is equal to 0. So this leads us to believe that y is 0, and for this one, if we bring the 2 to the other side, we say that y is equal to positive 2. So we have two solutions then for y, and we can now plug these guys back into our equation here to determine what x is, right? All right, so for the y equals 0 case, we'll have x is equal to 4 minus 2 times 0. Or in other words, x is equal to 4. So that's going to give you the point 4 for x, 0 for y. That's our first ordered pair solution. Now, if y is equal to 2, in that same equation, we'd have x is equal to 4 minus 2 times 2. Which means that we have 4 minus 4, which is the same as 0. So that means that x is equal to 0 when y is 2. So when x is 0, y is 2 is another solution. All right, so those are our final answers for the problem. There are two ordered pairs solutions for the system, 4, 0 and 0, 2.